All right, good morning, everyone. Today is Thursday, November the 4th. We are on day 3 of this 4.02. Yeah. So after today, you do the learn and practice module examples and work through that. Take the quiz. This problem from bell work is from yesterday. The answer is n equals -4/3. You can check out the recording yesterday for that work if you want to see it. Okay, exponential growth and decay. All right, again, make sure you download those guided notes. It has all these formulas on there for you, so you don't have to spend time writing them down during this class time. All right, so we'll be using these two formulas today. N equals n sub 0 or n naught times 1 plus r raised to the t power. And then the decay, you just have the little difference of being a minus of a plus. N naught represents the initial amount and represents the final amount. R represents the rate per time period, and T represents the number of time periods. This formula right here, we're going to use in 4.08. Is that what it says? Yeah, 4.08 when talking about radioactive decay and bacteria or population growth. Similar to this, and as far as I know, you can actually use these, at least for the growth, actually for growth or decay, interchangeably. You're going to have slightly different numbers, but this is another formula to represent when you have, well, growth and decay, exponential. And in 4.08, we'll talk about that. All right, let's get into it. All right. Initially, 25 bacteria are placed in a petri dish. It is observed that the bacteria double in population every 6 hours. All right, we'll be using growth or decay equation. Yeah, definitely growth. Definitely growth. Also, when talking about living things such as people or even bacteria, when you get your final answer, make sure you round to the nearest whole number. It's not going to state it, but you need to round to the nearest whole number. You can't have part of a person. You can't have part of a bacteria. It's either you count it or you don't count it. So again, for this, it goes without saying that you need to round to the nearest whole number. All right. What do we use for n naught? What do we use here? 25. Yep. And then for the rates on the side, let me just show you and explain. So kind of confusing if you haven't dealt with it, and people confuse this all the time. So for example, double, the rate is 100%. So if after every, let's say every second, it doubles, you get 100% more, right? So you go from 1 to 2, 2 to 4, 4 to 8. So when it says double, R is 100%. And when you move the decimal over 2 places, R equals 1. If the problem says it triples, R is 200%. If you think about it, 200%, you're getting your original amount twice, plus your original amount, well, there's 3. That's why it's triple. And you'll see how that kind of interacts with this 1. So triple, R is 200%. 2, quadruple, R is 300%, or 3. And then let's what we got. And then T for time. And then so this is the time, but it's time every 6 hours. Now this part's important when using this formula. It's time every 6 hours. So if t equals 6, well then 6 over 6 is 1. If the time is 12 hours, 12 over 6 is 2. So time is 2 times, right? Twice. So make sure it's always your time over, in this case, whatever that duration may be. In this case, the time period is every 6 hours. Hopefully that makes sense. Super important, because without this 6, this number right here would have no place to go. All right, so here's our formula. Oh, and then we have to simplify it. 1 plus 1 is 2. So it kind of makes sense. If you see this 2, it, in a way, it kind of makes sense when it talks about it doubles. Well, there's that 2. So the formula we have is the final amount is 25 times 2 raised to the t over 6. All right, how many bacteria after 6 hours? So what we're going to do is we're going to plug in that 6 in for t, and we're going to, well, we're going to type it in our calculator. So everyone, type that in and tell me what you get. And yes, you need a calculator if you don't have one. You probably should take in personal finance or consumer math. Even then, you need one. And I say it a lot, guys. You need a calculator. Yeah, 50. Which makes, and don't forget your units. On a TGA, if you just put 50 and didn't put bacteria, I will mark the entire thing wrong. So 50 bacteria. I understand in chat you're just putting the number. That's okay, but make sure on your notes you actually put the units, which makes sense. So without even using the formula, and if you typed in, or not so typed in, if you thought about this, well, it's 25 bacteria. It doubles every 6 hours. So how much bacteria after 6 hours? Well, it's going to double. So without even typing any of this in, we should know just by reasoning through it that it's going to be 50. But by typing it in, in a way, we verify that our equation is correct. Okay, now try this one. Now, how much bacteria after 20 hours? So we got 252 bacteria. Anybody else? Yeah, 252 bacteria. Pretty easy, right? Not much to it. All right, let's try this one. Initially, 37 bacteria are placed at a petri dish. It is observed that the bacteria triple in population every 5 hours. So everyone, go ahead and set up this equation. And in chat, go ahead and write down what your equation is. Yeah, 36 times 1 plus 2 raised to the t over 5. 37, yep. Yeah, very good. And then we simplify. Good. Okay, everyone, go ahead and Find out how much bacteria after 12 hours. Got about 517. I agree. 517. Good. By the way, if you didn't know this, this wavy equal sign means approximately or about equal to. So this is the approximation symbol. If you notice on the last one, I put an actual equal sign because it was exact. Well, this one this one is rounded. Now you don't have to do this. I do this, just habit. But this means approximately. All right. What about after 24 hours? How much bacteria? 7217. Anybody else? Just wait for someone to make a rounding mistake so we can talk about it. But don't do it on purpose. Yeah, make sure everyone's typing it in. If you're just guys, if you're just watching and then just getting the answers, I promise you that's not going to be helpful. You need to show and prove to yourself that you know how to type this in. The hardest part of this stuff we're doing right today is typing it in and getting the right answer. So it is 7217. Okay, compound interest formula. All right, you've probably seen this in past math classes for sure. So we have a formula where you compound yearly. Um, when it says yearly, this could be um, the number of compounds, which is n, could be compounded daily. It could be compounded monthly, compounded um, semi-annually, or compounded annually, or whatever. You would use this formula. Now, if you are compounding continuously, so think of this being basically compounded every single second. This would be compounded continuously. P is the initial investment. A is the amount after given time. R is the interest rate, the annual interest rate, converted into a decimal, of course, just like on the previous two formulas for the growth and decay. N is the number of times that you are compounded each year. And then T is the time in years. That's important. So let's talk about compounds. How many times per year? So annually, how many times per year is that compounded? One time. Let me write this down. One time. What about quarterly? Yeah, quarterly is 4 times a year. What about monthly? How many times per year? 12 times. What about bi-monthly? So you would think it's 24, right? You would. Um, I honestly hate the word bi-monthly and bi-weekly because there's actually two meanings, and I let me move my invisible box here. So bi-monthly could it either means twice a month or every other month or every 2 months. This is why I hate the word bi-monthly and bi-weekly, because also bi-weekly could either mean twice a week or every 2 weeks. The English language is dumb. Um, so I don't. I highly doubt. It's highly doubtful that the modules will give you problems that say bi-monthly, just because it's confusing. Because you're like, well, what do you mean? You mean twice a month or every other month? At least that's what I always think when I see this. Or bi-weekly. I'm like, is that every 2 weeks or is that twice a week? I don't know. Um, and then daily. What is that amount every year? Yeah, 365. 365. Yeah, I'm gonna say if they say bi-monthly, I'm gonna say they probably are going to mean oops, not that one. Not that one. They're probably gonna mean every other month. That is my guess. That's what I would probably go with if I saw that. Just because my reasoning is people use bi-weekly as every other week, so why wouldn't bi-monthly be every other month? That is my only reasoning. But I honestly hate when people use biweekly. I wish they would just say like every other week or twice a week because that is very clear. Food for thought. All right, so now we got two more formulas. Oops, these two. We have compounded yearly and compounded continuously, along with our growth and decay. All right, I meant to cover this up, but yes. So you open a bank account that accrues 1.1% interest monthly. If you initially put in $500 in the account and no deposits, English hard. I'm gonna guess maybe and no deposits or withdrawals are made. Yeah, probably. Um, and no deposits or withdrawals are made. How much will be in the accounts after 5 years? All right. All right. So what's our A value? That's what we, yeah, Naomi's right. We need to figure. That's what we need to figure out. Yeah, we don't know what that is yet. Yeah, remember A is the amount after we're trying to figure out. So nice job of those I didn't trick. What is our P value? Wasn't a trick question. Well, yes, I did it on purpose to see who I would trick. Yes, 500. All right. What is R? And make sure you convert to decimal. Convert it to decimal. Convert to decimal. It's in a percent. 1.1 is a percent, not a decimal. Come on, pre-calc students. Let's convert 1.1% into decimal. Let me give you a hint. 50% would be 0.5. Mm-hmm. Mm-hmm. So what is 1.1%? Uh-oh. Oh boy, haven't seen a right answer yet. Oh boy. All right, let me write something down on the board. So my little example, 50%, 50% is equal to 0.5. And you're wondering, well, how did I do that? Well, here's the decimal. We move it over two places. 1, 2. Look familiar? There we go. Ryan got it. Yeah, 0.011. Yep. Or 0.011. So I think the reason why, and I should have done it, the reason why you see 0 in front of the decimal is to kind of point out the fact that there's a decimal here. Just, I guess, makes reading it, I guess, easier to see it, that there's a little dot right there. But anyway, yeah, 0.011. What does n equal? 12 is correct. Why is it 12? Yeah, it's monthly. It says it right here that it's monthly. So it accrues 1.1% interest monthly. A little tricky because it didn't explicitly say, hey, by the way, we're compounding monthly. This implies it. This little statement right here. Interest monthly. Okay, what is the time that we want to find? Oh boy. You are all a little rusty, don't you agree? Little rusty this morning. We'll get through it. All right, so let's set this up. All right, we're going to have our p-value, which is 500. We're going to have our 0.011 in the numerator. We're going to have the 12 in the denominator. And then in the exponent, just like the formula says, is n times t, so 12 times 5. So the nice thing is once you actually have everything written down here, you just literally just transfer it over to the formula. All right. Now the fun part. Let's see who can type it in. This all should have been the easy part. That was loud. This right here is the hard part for a lot of people. So everyone type this in and tell me what you get. If you have an FX 300, FX 115, this makes it so easy. Naomi, Rachel, don't you shortchange me. This is money. I better have change in my bank account. It's my money. How dare you? How dare you? By the way, these problems aren't going to tell you how to round. You need to think the context. Hey, it's people, it's bacteria, it's going to be a whole number. Money, you better have two decimal places. Well, because it's money. $528.26. Silly question. Where does the dollar sign go? Hmm. Is that a question or are you sure? Yeah, it goes in the front. Goes in the front. Yeah, so it is $528.26. So one thing, yeah, guys, always put dollar sign in front. And so in the United States, that's where it belongs. It doesn't go after it; it goes in front. All right. So hopefully everyone that's here, everyone that's watching this recording, you pause the video if you're watching it and you type this in to make sure you get the correct answer. You will miss every single question on your test and on your quiz if you cannot type this in. All right. So what if it accrued interest daily? What if it accrued interest daily? How would I change this formula? Yes, it's going to be word problems. What's wrong with word problems? They're my favorite. Yeah, change the 12 to 365. Yep. All right, everyone, go ahead and type that stuff in and tell me what you get. So Rachel got 528.27. Yeah, it is very close. I agree. Oops. You are correct. So why so little difference? Why is there only a penny difference? Any ideas? What are some factors that you think lead to only a penny difference? Nobody knows? Or you're still typing? Because it's divided by a bigger number than 12, but also multiply it. Okay. Well, so the reasoning I want like real life reasoning, not this mathematical dividing stuff reasoning. I want like situational reasoning. Yeah. So the interest monthly isn't changing. I agree. Same amount of time. It's still for a year. Okay. Yeah. Also, just want to point out, I'm just kind of stating the obvious here. The interest that accrues is only 1.1%. That's not a whole lot. So the fact that even though we are compounding daily instead of monthly, the interest amount itself is not, it's 1.1 is super low, super low. So it has a pretty small impact. Now let's say it was like 8% monthly and and you compounded monthly versus compounded daily. At say 8% will have a larger impact than say 1.1%. Also, the amount invested, $500. Well, in the grand scheme of things, not a whole lot. Now, if this number was like maybe $5 million, $5 million, $5 million, and they did that, then looking at the dollars amounts, like, yeah, that would actually kind of be pretty substantial. So, yeah. So basically, low interest rate and low amount invested. Okay. Next problem. A sum of $9,000 is invested in an annual interest rate of 8.5% compounded annually. Find the balance in the account after 3 years. Now, I meant to cover this up, but looking at our four equations, which equation are we going to use? Or which formula are we going to use? Anybody? Out of these four formulas, which one are we going to use? Compounded yearly. There you go. All right, everyone try this problem. I'm going to give you all like, say, 2 minutes. And then when you finish, give me the green check mark once you have an answer. I want everyone to have a chance to type this in and get an answer. And again, typing it in is the hardest part of this lesson. At least it should be. All right, waiting for one person. Looks like they're tabbed out though. Oh, they're back. And I've said it many times. If you're using your computer calculator, you need to get one. You need to get one. Okay, everyone, what is the What is the final answer? What did you get? How much money is in the account after 3 years? Ooh, see, I like seeing everyone's answer because if you notice, everyone is really close. I see somebody just, oh, maybe entered it wrong. So look at the numbers. We got $11,495.60 after 3 years. So let's see, 49560. So then we got someone that had a decimal moved over, looks like one place. So check what you entered. So let's talk about. I'm gonna pick on. I'm gonna pick on Ryan, just because it looks like when you entered it, you forgot to enter. I'm guessing you forgot to enter one of the zeros. That's what did it. But if you look at the amount we're starting with, $9,000. Look at the $9,000, and Ryan, I'm looking at your answer of $1,000. It's just a little over $1,000. So looking at the amount after you account for 3 years and the starting amount, does it make sense? Like if you were the one that invested $9,000 and then after 3 years you're like, where did my money go? Would that make sense to you? It doesn't. It doesn't. So yeah. So yeah. So yeah, you did enter 979,000. So these word problems, these real world situations, look at the answer you have and see if it makes sense. And going from $9,000 to less money doesn't make sense, and it should kind of trigger something like, hey, where my money go? And then let's look at everyone else who got it. So we got 60 cents. Uh, we got. Did everyone get 60 cents? Yeah, everyone got 60 cents. Okay, let's see if it is 60 cents. I don't remember if it is 60 cents. Um, all right, so after 3 years, all right. Yeah, so that is right. Everyone got it right. $11,495.60. All right, so we're solving for A, of course, and then let's put everything in there. All right, so let me just. And hopefully nobody entered this over 1 in your calculator. You should have just simplified this to just be 1 plus 0.085, or even typing it as 1.085. But hopefully, if you see you can simplify some stuff like this or like this, you do that before entering it. It'll make entering it a little easier. All right, and then what is the amount after 5 years? I saw one of you already entered it. Let me scroll up. So you said it was $13,532.91. All right, so we got another one with 91 cents. We got someone else that has $13,765.63. So you're off by, I don't know, a couple $100, a little less. Um, yeah, so let's take a look. So all of you, whether you're right or wrong, are pretty close, within a couple $100, it looks like. But in this class, if you're not exact, it's wrong. That's how I grade. So it is $13,530.91. Oh, yeah. So this problem, okay, I see what you did. Yeah, you entered you're thinking of the one that we're doing, this one or this one. So this one, we are compounding just annually, once a year. So yeah, that would definitely change the answer. All right, everyone, go ahead and find the answer for what if it accrues interest daily after 5 years. So I want you to calculate that balance. if you accrue interest daily instead of yearly. And give me a green check when you finish that part. Right, everyone is finished. So, what is the answer for the amount after 5 years if you compound daily? So, we got 63 cents. Okay, so it looks like everyone's having the same answer there. Let's take a look. Yeah, I agree with all of you. Very good. So, we had to change into 365, of course. And you get that. Very good. Nice job, everyone. Okay, and then this last one, give me a green check when you finish the last question on this page. What if it compounds continuously after 5 years? The E is a constant. So you need to find E on your calculator. It's usually with your LN button. So natural log. So log, natural log should be side by side. And then you might have to hit the second or the shift key and then hit the LN button to get the E. So it's a constant. It's like 2.7 something or other. I don't know. Well, we're going to use E a lot more this unit. It's kind of like pi. Pi is a constant, 3.14159 something or other. Guys, make sure you get your units free stuff done, your test and your part twos. All of you in the live session, I'm guessing probably already have it done, but people watching the recording, like half the class hasn't even done it yet. Like I just don't get it, and I put in zeros yesterday for people who didn't have it done yet. I would hate to fail the half the class because you fell behind. Unit 3 was it was long and difficult, and then unit 4, it's short, but it's only difficult if you wait to the last minute to try to learn everything. It's yeah, good luck. Um, and I've said this before, but if you have anything lower than a C in this class, you will not be going on to next semester in pre-calc. You'll be going to a different math class. Um, People who have below a C, like D is passing, but if you get a D in this class, I would bet money you wouldn't pass next semester. And really, people who don't go on to next semester, it's not because you don't have the ability. It's because you were lazy and you fell behind. That is really the only reason. Um, if you stay up, stuff is difficult, but you'll get through it. So yeah, we're probably gonna lose. I would say probably like a quarter of the class is my guess. Maybe less, maybe an eighth of the class. I don't know. I think last year I started with. Actually, I have to look. I don't know. I feel like I started with like maybe close to 200 students in the class. No, maybe not that many. Maybe like 180 or 160, and then second semester I was down to like 100. I don't know. I forget. Yeah, it's kind of a lot. Yeah, I'm actually still losing students. Like we lost another one the other few days ago off my roster. All right, guys. What is the answer to this problem? Everyone's done. We got 31 cents, 31 cents, 31. I used E. Nice. All right. So I'm only saying the change because that's where people like none of you have made a rounding mistake yet. At least if you haven't typed your answer yet. Um, yeah, I agree with those putting their answer in chat. It is $13,766.31. And because it was compounded continuously, all of you did a good job and used the correct formula. Very good. Now, if you notice, do you see how after 5 years, so both of these are after 5 years, this is compounded, was it annually? So compounded annually, we only made 13,005. Well, we didn't make, we now have $13,530.91. And then if we compound it continuously after 5 years, we'll have this much money. So like 200 and like, I don't know, $40 or so. So about maybe $240 more if you compounded, well, continuously. Kind of makes sense. And this one has a larger impact because, well, the amount we're investing in our account is a lot higher than $500, and the interest rate is a lot higher than 1.1%. So it makes sense that we would have a larger difference between these two, compounded once a year versus compounded continuously. Just want to point that out. We got two more examples here. We got this one and this one. And we got about 4 minutes. Luckily, we only have like one part. This was kind of like 4 problems in one. So we got Just these two. These will go quick. All right, everyone, do this problem, please. Today, there are 11,358 students enrolled in a university. This enrollment is predicted to decrease at a rate of 2.3% per year. What is the predicted student enrollment 7 years from now? All right, ready, go. Click the green check when you are finished. It looks like most of you are done, and just to save time, I will have to go on. Looks like everyone's done. Good. All right, what's the answer to this one? Ooh, 9651 students. 9651 students. 9650. Oh, okay. 96. Okay. Yeah, it looks like everyone's agreeing. Let's see if that's what the answer is. I also agree. 9651 students. So all of you use the correct formula. Remember, it is the exponential decay because it's decreasing. Very good. Very good. So let me just, and everyone converted their percent into a decimal. You all learned so quickly. Yeah, you plugged it in, and then you have the rounded. And I put the rounded answer just to show why it's rounded up to 9651. Yeah, nice job, everyone. All right, one more, and we are over time. So if you do have another class to go to, feel free to leave. Or in fact, you can just open up your other class and just leave this one open, and you'll hear two teachers talking. How fun is that? Up to you, though. All right, last one. And when all of you finish this one, give me a green check mark. All right, what is the answer to this one? 75, 565, 68 cents. What else we got? Same thing? Okay. Anything else? Same thing? Okay. Let's take a look. Just clear this box out and row. Uh-oh, indeed. So Ryan got 61, 403 cents. So a little bit more than I did. Wrong formula. Dun, dun, dun. So nobody got it right. Let's, or maybe I'm wrong. Let's, yeah, so it looks like everyone is in disagreement here. It's okay. So I had two problems, one with the TS7 and one with the TS7 over 12. I didn't know which one was correct though. Okay, now fair enough. So this one, so let's talk about it. The value of a parcel of land now worth $60,000 expected to increase at an annual rate of 3.35%. What is the predicted value of the land 7 months from now? So it does say an annual rate of 3.35. So so it's, and this is money. This is not talking about like a population growth or decay. This is money. So it would make sense that we would want to use either this one or this one here. So our initial amount is $60,000. The rate is 3.35. Now, how did all of you convert that into a decimal? What does that look like? 0.0335. Yeah. Okay. Good. Or 0.0335. All right. Now the time. Trying to make sense of what my work is. So it is. So it's 7 months. So here's the thing with the 7 months. Remember this. The equations for the financing equations here, the compounded yearly, continuously. This is all based off per year. So the T is a year, and because it talks about 7 months, we have to write it as months. So you have 7 out of 12 months. Remember, 12 months in a year. So that's why it's 7 over 12. And it looks like, I think one of you actually said that in chat. You put 7 over 12. So, okay, so I did 2 problems, one with the last TS7 and one with the TS7 over 12. Yeah, 7 over 12. And hopefully by looking at that, it makes sense because it's months and not years. Now, if that said 7 years, then yeah, T would be 7. But because it's months, you got to be careful because this formula is in regards to T being years. Hopefully that makes sense. So we just plug that stuff in. It's compounded every year. So that's why we have a 1 for n. I should have wrote that in. I'll write it in now. N equals 1 because it's compounded yearly. And then, so we have 7 over 12 in the exponent. Kind of tricky. Now, was it? Let's see who did it both ways. Naomi, did you get the same answer for doing it this way? Okay, good. And I'm guessing everyone else, did you put a 7 for T and just put a 7 here? Yeah. That makes sense. All right. Is everyone satisfied with the reasoning and why it's 7 over 12? Little tricky. Okay. Good. And hopefully all of you quickly kind of just changed your calculator to type that in to make sure you get the same answer. So, all right, good. All right, guys. Well, that's all we have. Sorry we went over time again. I'm notorious for doing that. But as always, thanks for coming, and I hope you learned something. I'll see all of you tomorrow for our next lesson.